Welcome to Man Does Tech, where I solve the problems you didn't even know you had.
You start by defining the task precisely. Classification, regression, or generation, because that choice dictates data and loss. Once done, acquire and inspect a small labeled dataset. Look for missing values, class imbalance, and obvious errors. Make sure to pick your stack now: Python with PyTorch or TensorFlow, and an environment like Conda or Virtualenv. Then create reproducible code structure and version control. These first steps get you running immediately and prevent wasted time later. You now build the core, design a minimal model architecture that can learn the task. Simpler converges faster and highlights data issues. Then implement a robust data pipeline, batching, augmentation, shuffling, and normalization, so training sees clean, varied examples. Once implemented, set the loss function, optimizer, and a learning rate schedule. Log metrics and save checkpoints regularly. Run short experiments, inspect learning curves, and iterate on model capacity and data augmentations to improve validation performance. You finish by evaluating the model on a held-out test set and interpreting metrics to ensure real performance. Once satisfied, optimize for deployment. Prune, quantize, or distill so the model meets latency and memory targets. Then package the model with inference code and tests. If things go wrong, diagnose systematically. Check for data leakage, label errors, and whether you are underfitting or overfitting. Run ablations and smaller experiments to isolate the issue and fix data or capacity accordingly.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.